Okay, so for chapter 8.2, we're going to be taking that idea from the sample means and we're going to construct what they call a confidence interval, and which allows us to say that, well, while we can't be sure, we know that the sample mean is not the actual population mean, we can use that as an estimate and say that we're confident that it's really in this range. Okay, so that's what you're going to be doing with this. That's how we get around the fact that we know that sample means are not the exact value, but we can use this as an estimate by giving a range of values. So when we have the sample mean, that's the best estimate we have. But we want to like I said, we want to have a range of numbers and say, well, we think it's somewhere between here and here, and that's what we're going to use. That's what a confidence intervals. And that's all this talk here. So remember that we said 2 standard deviations, 95%, about 95% of the data is within 2 standard deviations. Well, the exact value is 1.96 standard deviations. And that's why we say, well, it's close enough to 2. So that's where that idea comes from for the 68, 95, 99.7% rule. So because it's a little more than 95%, we're estimating that at 95%, and 2 is an easier number to use than 1.96. So if we're 95% confident that a mean is inside a list of sample means, an interval sample means, that says that one out of every 20 of them is going to be incorrect. Will not actually have the population mean in it. Okay, and so the confidence interval has a margin of error, and the margin of error is calculated by taking 2 standard deviations and dividing by the square root of n. So that then margin of error is added, it's subtracted and added to our sample mean to say, well, we believe that the population mean is between these two values. Okay, so we subtract the margin of error and we add the margin of error, and we can write it like this, or sometimes we say x bar plus or minus e. Okay, where e is the error. Okay, calculated through this. Now 95%, because remember 2 standard deviations is 95% of the data, that's where that comes from. So on a graph it would look like this. We calculate our sample mean, and so our margin of error less and our margin of error more, we're going to have these two numbers and say that we're 95% sure that the population mean is between these two values. And if we take a lot of these, in this case we've taken 20 of them, if we're 95% confident, then one of those values will not contain the population mean, because that's what this value is here, this blue line coming down the center. Some of them are less. Sometimes our sample mean is more, but notice all these pink lines are our margin of error. Well, we have our less than and greater than, so they all contain it. These 19, this 20th one did not. Okay, and that's how the idea of 95% confident comes about. So it's not that we're 95% sure, it's that 95% of the time we will create a confidence interval that has the population mean in its range. Okay, so to calculate margin of error, they're going to ask you to calculate 95% margin of error. We have an n of 267, a sample mean of 77 grams of protein. Okay, this is protein intake, and a standard deviation of 58.6. Well, it's just pretty large. So because of this, we have to calculate our error. Well, our error is 2 times the standard deviation divided by the square root of n. So we do that out, we get 7.2 as the margin of error. That's all they're asking. If we were then asked to calculate the 95% confidence interval, we would take that 7.2 and add it to the 77 and 7.2 and subtract it from 77, and that would give us our range, which is what they're doing next. We say, okay, so we have a 95% confidence interval. So first we calculated our error. Then we find our confidence interval. Well, we had that 7.2, we subtract it from 77, we get 69.8. We add it to 77, we get 84.2. So what we're saying is that we are 95% confident that the population mean for protein of all American men is between 69.8 and 84.2 grams. Okay, and so here they go on to say, give us some interest, that the protein allowance for men is between 55 and 60, so even the lowest value is more than we should be taking in. So here's another one. We have 8th graders watching TV, okay, with a margin of error of 0.4, and they want to construct a confidence interval. Well, they've given you the margin of error and they've given you the sample mean, so all we have to do is subtract it and add it, and we get our confidence interval. So it's somewhere between 6.3 and 7.1. So this is what they're saying here. And then if we're interpreting it, if a 95% confidence interval says that if we took 100 random samples of the same size, we would expect 95 of them to contain the actual population mean. 95% confident. That's what it means. Okay. 19 out of 20. 95 out of 100 times we will have the population mean. So that means 5 times we're going to not have. We can still use it as our confidence as our confidence interval, but it may be wrong 5 times out of 100. So the other thing we can do with this confidence interval error is figure out how many people should we survey. So here we were getting our error. We were finding we had a sample size, and we had our standard deviation, and we had our mean, and we were calculating our error. Well, now we're going to say, well, how many people should we survey? Because you've always asked me, well, how do we know how many people should they survey for these things? Well, what we do is we solve this for n. We take this formula, E is equal to 2 times standard deviation divided by the square root of n, and we solve for n. Well, that means first we're going to multiply both sides by the square root of n, then we're going to divide by E. Then to get n alone, get out of the square root, we square both sides. So we have 2 times the standard deviation divided by our error squared, and that will give us how many people we should survey. So if we don't know sigma, okay, which in most cases we don't, that's why we use our sample standard deviation of S. Okay, or a previous study's sample standard deviation. So here they're going to construct a confidence interval. First we have to figure out how many people do we need. So if we're going to do a 95% confidence interval, and a previous study we found that the standard deviation was 7,200, how many people should we survey if we want our error to be 500? Well, 2 times our standard deviation divided by our error squared. So 2 times 7,200 divided by 500, that comes out to 28.8 squared, which is 829.4. Well, we can't survey a 0.4 of a person. And if we go to 829, we're not going to get our error is going to be actually bigger. So we want to go to the next person, or 830 people. So you're always going to round up in these cases. Okay, we should say, and now here it says at least 830. If we want to have an error of 100, we do the same thing. 2 times 7,200, in this case divided by 100 squared. We find that we have to survey over 20,000 people. So that's huge. We have 25 times the amount of people so we're actually better off probably getting an error of 500 than we are dealing with an error of 100, because this is maybe cost prohibitive, this 20,000 people. So you can give up accuracy. It's okay. To be, if you can't afford it, if to survey 20,000 people, first off, you have to get 20,000 people to go through your survey, and that may be bigger than your population. So you have to get that into consideration as well. So be realistic when you're doing studies. That's it.